Hello everyone. Today we're gonna solve the search in sorted right problem. This problem is giving us a sorted array and then rotated it, and they give us a target number and need to return this number in our sorted array. I mean, in our rotated array. And what we're gonna do, we're gonna write an algorithm within the O log n runtime complexity. So this problem is very easy if we just need to find the position. So we just need to use a loop through all of the position. Then we're gonna see whether or not this target where's the target. But if we use this approach, it's gonna be on, and uh, how can we use an O log n algorithm to solve it? So let's first talk about what is a rotated array. A rotated array means that an array first of all is already sorted, and then we will move some of the element on the front to the back of the array. For example, if we move three elements from the front to the back of the array, we're gonna have this sorted array. So now how can we search for the target number? Let's say the number 0 in this array. The idea is very simple. First of all, we need to find whether or not our largest number, where is the largest number in our array. So we can find it very easy because we know that this this is an increasingly array, and this one is also an increasingly array. So we can use this condition to search for the largest number, and then we can based on the first number in our array and the target number. For example, we have this one is the target, right? We're gonna see if our target number is less than the first number in the rotated array, which means that this target number cannot be in this segment, right? If we have the target is less than 4, less than num 0, which means that we cannot find target in the segments from the first element to the largest one, right? So that's why we're gonna find in the remaining array from the largest number position plus 1 to the end of the array to find it. And if we have the opposite condition, otherwise we will find in this array, right? So it's very simple. But if you see this problem at the first time, it's a bit hard to figure out how to solve it. So first of all, we're gonna find the largest one, largest position here, right? And then we're gonna search from the beginning to the largest ID, or we're gonna find our target in largest ID plus 1 to the end of the array. So that's basically the idea. And let's continue to the first part. So first of all, we're gonna consider some of the edge cases. Let's say we have the edge case when we have just 0 element, right? If we have 0 element, which means that we cannot find the target in our array. So basically, if we have the nums size 0, we're gonna return minus 1 here. And then first of all, I'm gonna get the size of our arrays, and then we're gonna get the first elements of the array. Then we're gonna have left and right. Then let's say we're gonna have the largest ID equal to 0, and then we're gonna look while left less than or equal right. We're gonna have to choose the mid position, and then we're gonna consider our mid position to the first one. If we have the number mid position is less than or equal our first element. If we have this one, let's say let's, let, yes, let's consider the opposites. So if we have the mid number is greater or equal than the first one, we're gonna know that let's say in this case, right, we have left right here and right here, and we choose this position, for example, and this position, for example, and we know that this position is greater than our first position, right? So we know that the largest one should be this one, or it should be in the range of this one, right? So what we're gonna do is we're gonna temporarily choose this one is the largest one, and we're gonna move the left pointer to the next one, to this, right? So what we're gonna do is that we're gonna choose the largest ID gonna be equal to mid, and then we're gonna have left equal to mid plus one, then else we're gonna have right equal to mid minus one. So let's consider this case as well. So let's say we have this range and we choose this position, right? And we know that this position is less than the first one. So which means that we cannot find the largest one from this position to the end of the array, right? So which means that we will eliminate all of these elements by moving the right pointer to this position, to mid minus one position, right? So which means that in the next iteration, we're gonna know that this position is the largest one, and we will stop the searching algorithm. And then after we found the position of the largest one, we're gonna see that if we have first of all, if we have the target number is the first position, we're gonna just return 0. Otherwise, we're gonna consider if our target is greater than the the first position. So which means that for uh we're gonna search for the position from the beginning to the first, the largest ID and the target one. Otherwise, we're gonna return from we're gonna consider the segment from largest ID plus one to the end of the array. So that's basically the idea. And then I'm gonna implement the binary search here. We're gonna have the left, right, and the target. Let's say we're gonna pass the vector array ternums. Well, We'll pass this by value. Do not change anything in one. And we have integer, and so I'm gonna text a little bit right here. Have number. So in this binary search, basically we just are gonna find the target number in this range. Very easy. Y left less than or equal right. We're gonna choose the mid position, and then we're gonna consider if the mid position equal to, let's say this one is right of mid position equal to target. We're gonna read mid position. Then if we have this one is a typical binary search, nothing fancy. If we have a if less than target, we're gonna move the right left go to mid plus one, and else we're gonna move back to mid minus. And if we don't find anything, we're gonna return. Yeah. So that's basically the idea. And the time complexity, of course, is gonna be O log n, and the space complexity gonna be O1. The topic for this one is just binary search. That's all for this problem. Perfect. Thank you for watching my video and hope you guys enjoy it.